Assalamu alaikum. My name is Danish.
And myself Asnan.
We are students of Mining Engineering Department from UT Lahore, and we are assigned a problem. Uh, there is a mine located in Kalabagh area, that is a Union Council of Mianwali district, located in Punjab province. The problem is that the mine management is currently practicing longwall mining method, but they are facing high stress scenario, due to which there is a chance of failure. So, in order to tackle, the mine management has decided that they can transform their mine from longwall mining method into room and pillar mining.
To transform a mine, it requires analytical and empirical analysis. We have used different softwares and empirical method to design a pillar and rooms and layout plan for whole mine.
Here you can see the problem statement. There is a coal mine located at Kalabagh area. So you have to reduce the high stresses the mine management is facing. The maximum depth you can see here is from the surface is 800 meters, and the thickness of coal seam is 2 meters. The roof you have on your top is the Cura sandstone formation, that is 20 meter thickness, and the overburden is, you can see here, is the Chorgari limestone, that is 40 meters. The mine management is now want you to design a new method so that you can reduce the stresses and or you can transform the mine into room and pillar mine. Before we proceed further, one should know what is longwall mining and what is room and pillar mining. So basically, longwall mining is a highly productive underground coal mining technique. In this technique, multiple coal shearers are used, in which self-advancing hydraulic sealing support is also installed. These massive shearers cut coal from a wall face which falls onto a conveyor belt for removal. As a longwall miner advances along a panel, the roof behind the miner's path is allowed to collapse. Now, room and pillar mining. It is the most common mining system. In this system, a series of parallel drifts are driven with connections made between these drifts at regular intervals. The room and pillar mining is just like a checkboard pattern. We will proceed in a systematic way. The problem has been distributed into different sections and parts. So, beginning towards our first part, in this section, we will try to find different rock properties of sandstone, that is our roof, and the limestone. For this reason, we have used the RockLab software to calculate the rock mass properties of limestone and sandstone. Here is the software RockLab, from which you can enter your data input and you can have your results, that is the rock mass properties. In the next section, we have to know what should be the data for a geotechnical mine design. For this reason, these are some of the required data, or you can say the parameters, which should be known to devise a geotechnical mine design. First one is the core drilling data, second geological structure data, third ground condition data, and the fourth one is data regarding your size, shape or orientation of the openings. Moving towards our next section. In this section, we will try to calculate the in situ stresses. For this reason, we have used the analytical method, or you can say the formulas to calculate the vertical stress and the horizontal stress. The vertical stress calculated is 16.4 megapascal and the horizontal stress is 25.48 megapascal. In the next part, a problem arrived during the engineer's work. that the engineers did not able to acquire data using the flat jack. We have to give the reasons that why this happened. The reason can be that flat jack method is not able to measure the shear stresses produced, or the rock behavior is not reversible. These can be the reasons that the flat jack failed to produce results. Now, the next section is whether we can use the overcoring method to get the in situ stresses. Well, the answer is yes, we can use the overcoring method. Why? Because it can produce feasible results in these conditions. Here are the reasons why we will use the overcoring method. The first one is the induced stresses are calculated in this method, and this method has the access to virgin stresses, and also all the stress components are measured at a single point. So these are the reasons why we should use the overcoring method. Our next section is design based section. In this section we will design our pillars and rooms, or you can say the openings, and then we will check whether these openings are safe or not. So we have taken our opening width of 8 meters and a pillar width of 4 meters. Using the tributary area method, we have calculated the load on a pillar, which is equal to 69 megapascal. Now the factor of safety calculated to be is 1.6, which is a good factor of safety, that is our mine is safe. Next we have chosen that our mine is rectangular, or you can say the design is rectangular room and pillar design. We have used the AutoCAD software to make a layout of our mine. Here is the layout. Here you can see the pillars and rooms and a shaft of 8 meter dia. The crosscuts and openings are 8 meters. The pillar width is 4 meters and the pillar length is 20 meters. Next we have done our numerical modeling so that we can see whether the mine is stable or not. For this reason we have used the phase 2 software. Here you can see the pillars and the excavated part. So according to this figure, our mine is safe. As we have designed our mine, now we will move towards its support system. The support system used here is based on the rock mass rating system. We have given the GSI value from which we calculated the RMR value, which is calculated to be 67. According to this, the rock condition is good. So the support system installed here will be, you can use the bolts of 3 meter length in crown and which are spaced at 2.5 meter. Or you can apply the short crate of 50 millimeter. The places where you consider you should use short crate. Next we will see whether our tunnel is safe or not. We will see the stresses on the tunnel using the software FEM. Here is the image from which we can say that our tunnel will be safe. We can use the bolts if you want to increase the factor of safety. In the next section, we have to devise a strategy that how we can reduce the stresses while practicing the longwall mining method. For this, we can use the shields which are operated hydraulically we can vary the load capacity of these machines, or you can use the caving of roof, which we do intentionally, and then install the support system, or we can use the sacrificial opening for this purpose. Now next we have to see whether, or you can say what will happen if high stress development in a coal mine will be ignored. Ignoring stresses in a mine may lead to failure. It has drastic conditions. The results could be drastic. There may be subsidence, or there may be a roof fall, or a pillar may collapse, and there can be fatalities. Next we have that what will happen if we mine a huge deposit where the stresses are high. So when we are mining a huge deposit upon which there is a high stress, following are the consequences. There may be a rock burst, or there may be subsidence. The cracks may move, and if the rock is weak, the spalling will occur, or the roof may collapse. After conducting this experiment, or the problem, we have came to know that the high stresses can be reduced if we change the mining method, as we have done in this problem, that the longwall mining has been converted into room and pillar mining, so that the high stresses the mine is facing can be compensated. The mine transformation is done by following a complete engineering analysis and procedure. It is a critical job. The stability is the ultimate requirement whether we are doing any engineering problem. So according to the calculations, our new mine will be safe and feasible.
Alright guys, now you have seen that your mine is safe now. You have tackled your problem which was you were facing due to high stresses. Now your mine is safe, and that is just a small remedy you can adopt in your mining method. Thank you.